Hello, hello.
Morning.
Morning, morning.
Ich hoff's.
Hello, hello.
Nicht ein
Hallo.
Bitte, Orlando.
Gar nicht.
Hey, Bob. How's it going?
Good. How are you?
Good, good. We'll give people till 5 past before we get started. Should be a fun one today. All right.
Yeah.
Hey, Alexis. Looks like I see Brian Grant. I pasted the deck in the chat, so if you see it, if you don't see it, let me know. We'll get started in a few more minutes.
Hey, this is Solomon.
Hey, Solomon, how's it going?
Good, how are you?
Good, good.
Hey, Solomon. Welcome.
Is Brian Cantrell on by any chance? Trying to see what the 415 area codes are.
Hey, Chris.
Hey, Ken. Markio's attending. So we're just missing Camille, Sam, and Cantrell at the moment. Give it another minute.
I think Sam posted something in the Slack channel a few minutes ago saying he couldn't make it.
Okay, no worries. That's fine. We have quorum. Alexis, do you know if Camille is going to make it or not? She didn't send anything my way. Got Ben here.
He has not told me.
Okay. All right, no worries. It's about 5 past. Brian and Camille aren't on. That's fine. I think we'll just get started. Alexis, go for it.
Hey there, everybody.
Hello, hello.
To the 1st November meeting. Don't forget, next November meeting will be next week and not in 2 weeks' time as normal. This is because of Thanksgiving. Put it in your diaries if you haven't done already. Okay. So agenda, we've got some project presentations today and a few reminds on AOB type stuff. On the projects, slide 6, Chris and I have updated the project priorities and review backlog sheets. I would be grateful if people who are interested in the question about which projects should be joining or applying to join, or who are interested in putting their own projects forward, take a look at those sheets. And if you see gaps or you have questions, either comment on the sheets or get in touch with me and Chris directly, and we'll try and get things scheduled. In terms of storage and networking, we are hoping to have a readout from the storage working group and networking working group next Tuesday on the strategy for onboarding projects in those categories. And there's been a request from Brian for discussion of that strategy. So it's important, if you are somebody with a dog in that race. Okay, can you go mute, please, if you're not talking? Thank you. So please be on that call next week if you care about storage or networking. I don't think we'll have much time for discussion about those topics next week, but we can get it rolling, and I'm very keen that we have a face-to-face discussion about those things in Austin in December. Okay, so slide number 7. Congratulations to Notary TUF, projects number 13 and 14 in CNCF. Thank you to Docker for that. Okay, so now we move on to Spiffy. I think that's the right pronunciation, which is going to be presented by who, Chris?
Yes, is Andrew and Sunil here?
I'm here. Hey, Chris. Hey, Alex.
How's it going? All right, we're going to let you drive now.
Great. Are we, so just so we know, are we presenting the slides, or are you guys driving the slides? Or are we just
people are presenting on their own, so and following
okay,
along.
cool.
So just go for it.
Okay, sounds good. Well, thank you for making the time this morning. I know we have a tight schedule, so I'll jump right into that. Let's jump to slide 11 here, which is designed to provide you a little bit of context for what Spiffy is all about. So Spiffy is a set of specifications that try to describe how we think about identity, specific in the context of cloud-native workloads itself. It's comprised of a few items. The first thing is the Spiffy ID itself, which describes the naming format and conventions of the actual ID itself. We then also describe how we think that ID should be encoded so that it can be cryptographically verified in a production system itself. As of now, we're using X509 as the base into which we're going to encode these identities. And it also describes how we think a workload should be able to retrieve these identities and their SVIDs, which is the Spiffy verifiable identity document, from an actual running system. And that's described in something that's developing called the workload API itself. Spire is a tool chain that's designed to actually implement these specifications so that you can actually provide identity and attestation for workloads in a myriad of computing environments, starting with Google Cloud Platform, working very much with Kubernetes, and going beyond that as well. Let's go to slide 12. So Spiffy started off last year. You guys may or may not remember this document, but Joe Beta, one of my former colleagues at Google, started drafting this document way back in the day. And that turned into a tremendous amount of interest from a large growing population of folks who started to recognize some of the challenges that came along with networking-centric controls and key management types of controls, especially as they started to build out more distributed kinds of systems and platforms itself. I picked this up with Joe early on last year and continued to drive and understand the interest at a broad level. And with that, we decided that it made sense to really try to make a go of this project, because we felt like there was a critical mass of people that were interested in this, and there was going to be an even greater set of people that were going to be interested in as well. Spiffy, going to slide 13, is based on a system at Google called LOAS, which stands for the Low Overhead Authentication System. It's one of those pieces of infrastructure at Google that when you leave Google, you shed a tear for that, because it makes your life a heck of a lot easier in terms of being able to allow your systems and applications to be able to efficiently coordinate and communicate with other systems throughout Google's infrastructure itself. This picture here is a picture of Google's Niels Provost last year, who publicly mentioned LOAS officially for the first time. Up until then, LOAS had not really been discussed publicly except for 2 other instances in various blog posts and things of that sort as well. So it is a critical platform at Google that provides a tremendous amount of scalability, security, and efficiency for developers throughout the platform as a whole. Let me hand it off to Andrew, who will take us through slide 15 at this point. We'll jump into Spire a little bit.
Hi, folks. Can everyone hear me? Fantastic.
Yes.
So worth spending a little bit of time on what LOAS and by extension SPIFFE and Spire actually do. You know, we talk about these things in terms of identity issuance, but really what Spire is doing fundamentally is, and SPIFFE is doing fundamentally, is providing a framework for bootstrapping trust on the kinds of deeply heterogeneous environments that we're starting to see modern enterprises needing to tackle. And Spire helps simplify that problem pretty significantly in a couple of ways. Firstly, for services that need these identities, that need this initial need this initial trust signal that they can use to establish communication, trusted communication between themselves. We expose this low-level local, that is on the same kernel, API called the Workload API. It's a very simple API. It doesn't require any authentication, which in turn means the calling system doesn't need any pre-shared keys in order to access it. And a workload can use that standardized API to retrieve both its identity and credentials, documents rather, that prove its identity in a wide range of different contexts. Those identities, we'll talk a little bit about what they can be used for, but on subsequent slides, but you can use those identities in a lot of interesting ways. The workload API is consistent wherever it is consistently accessed, no matter where it's called from. But the crucial capability is we've been able to bootstrap trust into a range of different environments. So we do that by having a central registry of identities, policies that describe how those identities should be issued. And we describe those policies in terms of both process level metadata, so whether or not it's a particular Kubernetes pod with metadata associated with it, whether or not it's a Linux process ID, and also infrastructure metadata. So for example, is this node running on a kernel that happens to be in a particular AWS auto-scaled instance group, for example. More broadly, what we've provided is a rich plugin infrastructure that allows this workload API to be surfaced securely in a broad range of different environments. On slide 16, we'll start diving into some of the specific use cases. For Kubernetes specifically, we talk about, it can be used for a couple of interesting ways. One of them is, of course, to issue identities, to issue these seed credentials to workloads that are running inside Kubernetes, so that are a container that's been scheduled by Kubernetes. We can issue identities to workloads running in a single cluster, across multiple clusters, and indeed between Kubernetes clusters and workloads that are running outside of Kubernetes. Another use case as well is to actually simplify the deployment of distributed systems like Kubernetes themselves. So being able to identify the nodes, the role they play, and helping bootstrap PKI infrastructure that's necessary to run a system like that. You can extend that same capability to any other kind of distributed system as well. So tools like Cassandra, Chef, Puppet, Ansible, all of these can benefit in the same way. On slide 17, another use case, of course, is just direct authentication between services. A number of different ways you can do that. We've actually been working pretty closely with the gRPC team, and particular kudos to Justin Burke. We're working on explicit SPIFFE and Spire support out of the box for gRPC, so it's effectively just an authentication backend that can be leveraged transparently. Slide 18, that same model can then be extended to a range of other more or less every other square on in the cloud native landscape, basically. One of the most important use cases that we see is a secure introduction to secret stores, and therefore avoiding the turtles all the way down pre-shared key that's necessary in order to access a secret store. And then finally, slide 19. With this growing world of service mesh, a core problem with any kind of service mesh is again bootstrapping the identity for said meshes. And so we have some very involved conversations with Matt Klein and the Envoy team, with William and Buoyant and the Linkerd team, and a few joint customers as well, to provide a secure identity bootstrapping for those products. So those then have a way of establishing trust between different nodes. And then finally, slide 20. There's a lot of text in this slide. Really, the takeaway I'm hoping everybody gets here is that SPIFFE Inspire is designed to be extremely extensible from the ground up, and in fact, providing that extensibility and the community of the community around that extensibility is a core design goal of the project. So we talked about being able to assign trust to different platforms, like different orchestrators and different cloud providers, and so we provided a rich set of node and workload attester plugin points that provide that functionality for specific platforms and for specific environments. And we have a series of additional extension points as well. For example, if you want to use a different certificate authority, say you have a Vault implementation or a Thycotic implementation, you can back out to that in order to actually issue certificates and mint certificates. And we also have a number of plugins around storage of metadata and storage of certificates, so that customers can lean on existing infrastructure such as HSMs and TPMs as necessary. And with that, I'm going to pass it back to Sunil.
Okay, great. So let's go to slide 22. So Andrew's given us a good kind of overview of how we think SPIFFE is going to be, Inspire is going to be applicable to the broader ecosystem. A lot of other folks thought this as well. The first meeting here that you're looking at, or this image on slide 22, is an image of the first SPIFFE meetup that took place on December 6th at Netflix HQ down in Los Gatos, California. This included folks from Netflix, Twilio, Salesforce, Google, JP Morgan Chase, and Cisco. From that first meeting, going to slide 23, we've had a busy year, to say the least. We've gone from one meeting to a number of community meetings that have occurred on a monthly cadence basis. We do a quarterly meetup face-to-face. The most recent one happened last week in San Francisco, and the idea is to continue to bring this community together to talk about the value of service identity. Many of whom are thinking about this, who recognize this being an issue, but haven't yet kind of put the pieces together until they've had a chance to sit down with some of the members of the community itself. One of the bigger parts of our history was the actual announcement in April of Istio deciding to provide support publicly for the SPIFFE specification itself, and so that created a landslide of interest in the broader concepts around service identity itself. Looking forward, as you all know, we'll be presenting SPIFFE Inspire at Cloud Native Con in December. We're looking forward to that. And from there on out, continuing to build out our long, robust roadmap that Andrew will get into in just a few minutes. Slide 24 talks a little bit about kind of the scale of interest in the project more than anything else. I should make very clear that this slide does not intend to represent that any of the representatives from this logo are actively committing code. It's supposed to represent the fact that these are all organizations, or some organizations, that have all either participated in SPIFFE's events, have reached out to Sitel directly about what the heck SPIFFE actually is, and are possibly even contributing code to and time to both SPIFFE's specifications and the Spire code base itself. It's a very compelling group of individuals and organizations, many of whom you have firsthand experience with at the CNCF. One of them is AWS, which Alexis introduced us to back in August 2017 after joining the CNCF, and they expressed interest in learning more about the SPIFFE project. So we've been working with them and a number of other folks to figure out what's the value of SPIFFE Inspire in this world of service identity more broadly. Slide 25 is designed to kind of talk a little bit more about some of the governance structure. A few months ago, or actually probably about 2 months ago at this point, we put together our own technical steering committee, which is basically our governance board for the SPIFFE project itself. This slide showcases to you the members of that group, including folks from Sitel, Blend, Heptio, and Twilio as well. We've been having regular monthly meetings. In fact, our last meeting was last night, We record those meetings and we make those notes available for others to consume as well. Slide 26 is designed to showcase and talk about the licensing model. So very much aligned with the CNCF's model around Apache 2.0. Additionally, all the code submissions are accompanied with Apache and Google-based CLAs, either for individuals or corporate CLAs as well. And then last but not least, trademarks and domain names are clearly delineated and owned and ready to be transferred on a moment's notice itself. Let me pass it back to Andrew for slide 28 as we talk about roadmap here.
Sure, and I'll skip over some of the detail here and save it for the Q&A. But if you'll recall the previous slide, slide 15, we talked about we think about the product in terms of workload-facing functionality, so integration into different products, platform-facing functionality, that is integration into different platforms, such as cloud providers, and then core functionality, which is functionality that's core to the framework. It's core to the overall framework. We released the first public version of Spire at the end of September, and since then we've been on a roughly monthly release cadence, on a fairly predictable path to build out integrations above and below, as well as start to improve the robustness and user experience of the core product. Jumping to slide 29, this is looking at the roadmap as it extends into 2018. As we, the high order bit of this roadmap really is the release of Spire 1.0, which we're targeting for the end of Q3 next year. Spire 1.0 fundamentally means a number of different things. It means rounding out not just the integrations, but more importantly, the set of client libraries, the documentation, the helper tooling, and verification tooling that is needed to help support that ecosystem and support that community. In the platform, we want to prove out that this secure attestation model that we've been working on supports a wide range of different platforms, not just hosted cloud providers, but also on-prem shims such as VMware and OpenStack. And then within the core, we've been thinking a lot about what production readiness means within the context of Spire. And we have some feedback from our community, which is driving our roadmap here. We expect to revise that over time as well. But we have a number of items that probably look fairly common to any project that's considering production readiness. Stability of the APIs, a release management model that guarantees that stability and that integrity and prevents regression, and crucially, support for Windows is something we'll be looking at in 2018 as well. And that's it for roadmap.
So the last thing that we have is we want to say thanks. Slide 30. You can obviously find more information about the project. We're on GitHub. Obviously, we're on Twitter, and we have a blog that kind of talks about some of the demos as well. There's a couple of appendix slides there for fun if you guys want to go through that. Also want to say thank you to Brian Grant from the CNCF, who's agreed to sponsor Spiffy as a project. We're looking forward to working with him and the rest of you to determine the path into the CNCF. At this point, we're happy to take any questions that you guys might have.
I have a question. Can you tell everybody what SkyTail is? We might like to know.
Sure. SkyTail, it's pronounced Cytail. Cytail is the commercial entity behind Spiffy and Spire. It is the company that is going to be working on building a set of commercial implementations that in part build upon the existence and pervasiveness of Spiffy and Spire across the enterprise landscape.
You mentioned Kubernetes in one of your slides. Is that just simply for deployment? You mentioned cross-cluster communication. Would that therefore sit on top of the RBAC that's already in there to maintain roles? How exactly does that integrate fully with Kubernetes? And then my second question would be, if you're talking about full application integration in the Kubernetes space, have you also considered authentication out to storage and how that would work?
Yeah, sure. Hey, folks. So concretely, what we have right now with Kubernetes integration is that we can issue identities to a running workload within a Kubernetes cluster. So that doesn't interact directly with the RBAC mechanism that Kubernetes provides.
Okay.
There are a number of ways you could consider extending that so that it does. In terms of secure introduction to storage, there's one of the nice things about SPIFFE is it being sufficiently low level is that there's a number of we see this as the underpinning of establishing communication to more or less any third party, as in third party to the running process infrastructure. So yes, you could absolutely see a world in which these identities could be used to establish communication to a storage system. One other point, it's worth noting that the identities that are issued by SPIFFEs can be used by RBAC. SPIFFE itself doesn't reason about auth-z. It just provides the identity primitive.
Okay, thank you.
What's the end developer story?
Can I hear about Kerberos?
Sorry, was there a question?
Yes, there is a question about Kerberos. What's the plans?
So the plan is, as of this point, to spend some time studying that. The companies that we've been talking to that have expressed interest in SPIFFE thus far do not necessarily have massive Kerberos deployments. It's only when we've started to engage with some of the folks in New York City and some of the larger enterprises where this has come up. We're actively studying how to think about using Kerberos as a backing store for generating SPIFFE certificates, potentially even having a world where we can actually use Kerberos to connect infrastructure that's authenticated, in private data centers, connecting to applications and services that are authenticated using SPIFFE IDs and having a bridge between the two. I would say that the work there is really nascent. We're actively looking to spend some time with folks who are smart in this area. We're spending some time with folks like Russ Albury. Russ is at Dropbox, and he's one of the, or was one of the Kerberos maintainers for many months. So we'll be working with him and a few others to learn more about what to do there.
I'll add a little bit of color to that too. For the customers we have spoken to, they've been using Kerberos typically to identify single physical nodes on static infrastructure, and Kerberos is amenable to that because you typically want to pre-share a key to establish that identity and establish that trust. That's useful. And actually something that SPIFFE and Spire can back into. We can use that as a way of bootstrapping node identity and by extension workload identity itself. But Spire provides a couple of things on top of that. One of them is if you're running on a cloud provider where you can test identity directly through, say, the instance identity document or GC's metadata API, you can avoid that pre-shared key. And that's what we're finding a lot of Kerberos customers are doing. The other advantage we have is we can do process level attestation as well as node level attestation. So particularly important when I'm running, say, a Kubernetes cluster. If I'm using Kerberos to identify the node, I still need a way of being able to understand specifically, which container running in which pod is able to access its identity. And so Spire and SPIFFE provides that API as well.
I saw from the notes here that Solomon might have a question from the phone about developer experience. Solomon, are you still there?
Yeah. In the ideal end state, how much does the developer of the workloads being identified need to learn about SPIFFE? Is it something that's expected to become part of a standard developer toolbox, or should it be through a selection of third-party frameworks, or is the goal that it's completely transparent?
I think in the fullness of time, when we look at places like Google, where it's become part of the underlying fabric for all developer services at a place like Google, it's fairly transparent to the developers. They know it exists, they know what it's supposed to do, but it kind of does what it needs to under the covers. The goal in the near term is to make SPIFFE available in as many development frameworks and platforms as possible. We don't prescribe to know exactly what's going to be necessary for each developer group in every single platform. And so we're working actively with a wide variety of folks. In fact, we've been spending some time with the folks over at Docker to understand and think about how SPIFFE can be injected for use by Docker's customers. We've been spending time with Kubernetes, and we've been spending time with VMware and a few others as well. I don't think that in the long term, we expect SPIFFE, Spire, and any other reference implementations to require active care and feeding by developers themselves. That kind of defeats the purpose of what we're trying to do here.
Yeah, Alexis said that time is up, but I just have one comment, if I may.
Go for it.
Yeah, so to provide a little bit of context, this is based on the LOAS system inside of Google, and it's just dial tone for any application that you bring up on Borg, and people don't even have to think about it. And that's incredibly empowering. It's hard to overstate how important a mechanism like SPIFFE is. It's the single #1 biggest missing puzzle piece for enabling microservices in the cloud native ecosystem, in my opinion. As soon as you break one application into multiple applications, now suddenly you have the challenge of how do they securely authenticate with one another. And you can just turn off authentication and rely on network security, but in larger deployments that doesn't fly, and multi-tenant deployments that doesn't fly. The alternative is every application just uses its own ad hoc credential system, and then you have to deal with managing those credentials. You have to deal with rotating those credentials. A system like SPIFFE can just do that for you automatically. And we're going to talk about Istio next. If you have a single tenant application, the application potentially doesn't even need to know about the authentication mechanism in order to take advantage of it. If you're using something like Istio to actually control whether the network traffic is authorized or not, right? So, and there was also a question about how does this relate to RBAC, and Istio is pursuing authorization policy as well that's potentially compatible with Kubernetes RBAC. So why don't we transition to Istio so we can see how.
Okay, thanks, Brian. A couple of things. So I think, Brian, you may need to write all that down because that'll be the first paragraph of the documented submission. And so don't forget it, please write it down now. Can we have a show of hands, as it were, from voting TOC members on SPIFFE Inspire? I'm particularly looking for anybody who objects to moving forward with this to a written proposal with Brian as sponsor. Okay, so I'll take that as assent to go forward with Brian as a sponsor. Thank you very much. Brian, can you take the team through the next steps? Just one request. Can we emphasize Spire a bit more? Because I think that, it's the software that developers are going to use.
Yes, absolutely.
Great. So Istio time. Who's up next?
This is Dan Cerulli. Do you hear me?
We do.
Okay, thank you very much. All right, everyone, I will take the slides from slide 40, and also Nilesh Patel is on the line, and he will be presenting some of the slides as well. I'm Dan Cerulli. I'm a product manager that works on API infrastructure and open source at Google. So moving to slide 41. The reason Istio exists is that we see several trends that are happening right now that are making companies increasingly develop distributed applications. We see some of it, you see this move from monoliths to microservices. Certainly containerization is a big part of the reason this is happening. People are able to now build their applications with containers and deploy them with containers easily and repeatably. It's good for a lot of reasons, scalability, et cetera. And they're also moving toward hybrid deployments where there are different components of applications that are running, not only different components, but running in different locations. All of those things mean applications are more distributed than ever. Monoliths are going away, and you have all these applications that are very complex and feature a lot of communication between the different services or microservices, or nodes, whatever you want to call them, that really make up the application. So because there's so much more of this communication, the network is now part of the application, this communication is intrinsic to the application, there's some things you need. You need to be able to monitor all of that communication more than ever before. It's very, very important to get good monitoring, not just how many bits are going back and forth, but what your service dependencies are, what your latencies are, what your long tail latencies are, the kind of things that traditional network monitoring can't give you. Security is more important than ever. These things aren't going on a single box, they're going on many boxes across data centers, sometimes across the cloud. And security for that is very different than securing a monolith. And then finally, you need to have good control between your services. You need to be able to do rollouts in a repeatable manner. You need to be able to do canary testing, you need to be able to do blue-green deployments. So how you control the traffic between those has become very important. That's a problem statement. Moving to slide 42, Istio is a service mesh, and its goal is to connect, manage, and secure microservices. Now, we'll say microservices here, although in reality, it doesn't matter the size of a service, and I'm not sure if there's a precise definition of what a microservice is. The fact is that we want to be able to help people with all of those communications and really separate the things that should be done by developers and the things that should be done by operations people. Now, in many companies, actually, these are the same people, but there's still a separation of concerns, and it was just kind of referenced in the Spiffy and Spire conversation. There are things that you don't want your developers to have to worry about. You want them to be available, and one of the goals of the service mesh is to make these things available so that you're not building into each application or service these intrinsic things that you want them to be, as Brian said, like dial tone. Istio is being designed both for containerized and non-containerized workloads. We've done a lot of work with Kubernetes so far, but early adopters are telling us very loudly and clearly that when they need this security and they need this monitoring and this control, it's not just for their services that they've already moved to Kubernetes. They need it for all their services. We're building on another CNCF project, Envoy, which is a fantastic data plane. And in order to enhance that, what we're adding essentially is pluggable management and control planes that will allow real, better, finer control of Envoy and make it a powerful participant in a service mesh. And there's a bunch of things we're adding there: intelligent routing, load balancing, metrics collection, policy enforcement, and security with end-to-end authentication and eventually authorization. Moving to slide 43, I will talk a little bit about the architecture and what we're actually shipping with Istio. As I said before, it is building on top of Envoy, but it adds three control plane components up top. Pilot, which is used to give configuration information to Envoy. So every Envoy, as it starts up, will be talking to this pilot component to get its configuration that it should be enforcing. A mixer, which is a runtime component. It's pluggable. It accepts all telemetry, so it can report to downstream systems all of the logs, all the telemetry that's connected. It's collected. And Mixer is also used for policy checks. So Mixer can allow you to do authorization. Say, is a particular service allowed to call another service? And then there's a third service, which is the Istio Auth component. Istio Auth is used for distributing TLS certs to Envoy so that all the calls on the service mesh can be secured with mutual TLS. One thing you'll note in the picture, we have Envoy typically deployed as a sidecar proxy, and all incoming and outgoing traffic on a service mesh does go through Envoy. So when a service, say service A goes to call service B, it goes through an Envoy, which uses the configuration information it retrieved from Pilot to know how to route that, whether that service is running in the same Kubernetes cluster, running in a different Kubernetes cluster, or running off the, not in Kubernetes at all. Envoy knows how to route it. It also knows routing rules like, should I be diverting 1% of my traffic to a Canary instance? Calls are placed from Envoy to Envoy securely with mutual TLS, as I said. And then Envoy does policy checks and can even check in with Mixer to verify, is this service allowed to make this call? Is there a quota restriction, and has that been exceeded? Assuming that the call is allowed to go through, it forwards the call to service B. One thing to note, service A and service B completely unaware that Envoy and Istio are there at all. This service mesh is transparent to them. It can be a standard HTTP call, it can be a gRPC call on HTTP2, or it can just be a TCP connection. So the Envoys are all reporting telemetry, again, to Mixer out of band, so without hurting performance, reporting all the telemetry back. That's logging, that's monitoring metrics, it's tracing, so that downstream systems, whatever you want, this is a pluggable architecture. Mixer can report that data to downstream systems. So it's meant to be transparent. It is, allows the developers to just concentrate on developing their services, and gives the people running the services the tools they need to monitor these things, get great information about what we consider to be the golden signals. What's your traffic? What's your error rate? What are your latencies across different distributions? And not only that, but do that at a fine-grained level, at a layer 7 level. Is there a particular method that has a latency that's spiking in the 99th percentile, for example? Or can we require auth on a specific method? You can do things like route based on content and say calls that have this user agent need to go to a specific instance of the service. And I don't show one in the diagram here, but you can also place an envoy as an ingress proxy as well for traffic that's coming into the mesh that does not have an envoy sidecar. So that's a run through of the technical portions. Moving on to slide 44, how does this relate to other projects? Well, obviously, we were working very closely with Matt and the team from Lyft as they've developed Envoy for the data plane. And we've been working with them for quite a while now and have found them to be a great development partner. We are working closely with the team at Kubernetes. Not surprising, we're here at Google and they're here at Google. And working with Kubernetes lets us take advantage of, say, deployment. We can really transparently put the proxies in there, the sidecars. We can also use their service registry to populate the list of services. We're working with Spiffy. We're already using the Spiffy specification for our security as well. And since we announced in May, we've started working with a lot of other projects that have actively been doing their own integrations into Istio. And I've got a list of them there. It's not a complete list, but as you can see, it's really attracted a lot of community and a lot of interest from the community. And I think the final slide I will do before handing this off to Nilesh is the slide 45. So we started working with this, started working on Istio in GitHub in December of 2016 with IBM and Lyft. And we worked on it for about 6 months before we made an announcement at GlueCon last year. It really has been very well received. The community is, you can tell that there's a need out there. And as you can see, we've got some stats. It's gotten a lot of attention. There's three organizations right now have commit access. Between us and IBM, we've got about 35 people full-time working on this. And counting the other companies that are out there, we estimate another 50 or so from a broad variety of companies, as you can see, in addition to those I already mentioned: Red Hat, Styra, Cloud Foundry, Microsoft. The community is really building. We have meetings very frequently. We have meetups. We're starting individual working groups for security and config, a bunch of different groups that are meeting, some of them bi-weekly, some of them monthly, but there's a lot of interest in this. And with that, I think I will switch over to Nilesh, and you want to take from slide 46?
Can you guys hear me fine?
We do, Nilesh. Go ahead.
Yep. Okay, cool. Sounds good. So from the slide number 46, talking about the competition. So today we did not see short of any of like head-to-head competition, but there are various aspects of Istio, as Dan mentioned earlier, around the security, around the management piece, around the routing, around the traffic management. So some of those pieces have vendors today. So for example, if I specifically talk about the security and routing piece, there are definitely commercial firewall vendors which can be direct competitor into that space, right? If we talk about the fabric or microservices management piece, then Azure has their own Azure services fabric in place. There is also a vendor called Backbone.io, who is also doing the things into the similar space around the security, routing, and traffic management. So that's the way we really try to look at the competition today. Moving on to the slide number 47, which is a roadmap for the Istio upcoming 0.3 release. We have listed the whole set of features onto the website istio.io, but maybe I can talk about some of those features over here. So before the end of this year, the main features that we want to drive is to make sure that overall Istio is really production ready, right? So we as a team basically want to feel comfortable that when our customers run the Istio into their production environment, they actually get the level of scaling and performance which they expect from any of the production grade application. We are also supporting more of the features around the VMs. We are also doing the basic authorization for the RBAC. And as Dan mentioned earlier, we do not want to support only the Kubernetes. We also want to support the rest of the environments and the runtime platforms. So we are also doing the various improvements in that space. Moving on to the 2018, I think one of the major features that we would like to build upon is to make sure that your service mesh can actually span across multiple clusters and not just a single cluster. And we also want to support the global load balancing as well as the auto scaling support. That basically helps you to make sure that you can actually run your application across multiple clusters and you still get the can take the advantage of various features that the Istio has to offer. Moving on to the slide number 48, why we feel that Istio is a good fit to the CNCF. So first thing is that Istio really aligns with the CNCF mandate of being a cloud-native containerized microservices project, right? There is a lot of interest into the community around the Istio. So for example, one quick example I would like to give is that there are at least 3 or 4 meetups or events that we see per month that we are aware of where IBM and Google has sort of no direct involvement at all. So these are basically events which are getting organized at a grassroots level by the developers. So really, really good to see that. And last 1 month, we have also started seeing that the similar meetups are also popping up across Asia and Europe. So that's really good to see that people are actually finding the Istio quite useful, and they also want to educate the rest of the community around that. There are various blogs and sessions which are Istio-related sessions which are being presented in various meetups, webcasts, podcasts, you name it. And like most of them are sort of like without any involvement from the Google and IBM. So that's also really good to see. And the Istio is also being evaluated by the many companies at the enterprise. So just like name like some of them, SAP, Cloud Foundry, Adobe, folks from the Mesos, JP Morgan Chase, Lightband, Starbucks, Royal Bank of Canada, all of these guys are really exploring that how they can take the advantage of the Istio features in order to better manage that microservices mesh. And these are just like some of the guys that we have already talked to, but there are a bunch of other guys that we are actively talking today. And the last one is benefit to the community from the Istio. So the community will really get the engineering commitment both from the Google, IBM, as well as from the rest of the partners. And Istio today also complements with a bunch of other CNCF projects, for example, Kubernetes, Bigger and Time Platform, Jagger, Prometheus, Envoy, Linkerd, and a bunch of other tool supports, which is coming over the next couple of weeks. Moving to the slide number 49, which really talks about how Istio benefit to the CNCF. So we have built some of the deep integration and will be continue to build deep integration with the other CNCF projects, and we feel that will basically help to foster the adoption of entire CNCF stack and not just the Istio, right? Talking more from the community point of view, it will help to drive the adoption of other CNCF projects. So for example, today when we talk about the Istio in any local meetups, we usually run them under the Kubernetes platform. We use the other CNCF projects like Prometheus, Jagger, Zipkin, along with the Istio. So so that way we also sort of like make the people familiar or educate them about the other CNCF projects. And from the development point of view, someone can basically run their entire workflow end to end onto the CNCF set of technologies. So that's how we basically feel that the Istio would really be able to help the CNCF as well. Slide number 50, which is basically our ask to the CNCF. So it's on a couple of different fronts. First one is on the marketing. So we would like the CNCF to take over our Twitter account, as well as help us to coordinate with the various publications and the press to make sure that we get even more exposure and even word out there around the Istio. We would also like the CNCF help onto the organizing the events. Specifically, it would be great if we can get actually microservices for the Istio specific tracks in KubeCon and the Cloud Native Con. I think we can. Can you guys still hear me?
Yes.
Yeah, we hear you loud and clear.
Sorry, I actually just heard that I've been muted. Sorry. Onto the governance side, we would also like, I think we can also use your help in order to formalize some of the process around the project governance. Talking more around the CI/CD side, I think we can use your help to with the centralized CI infrastructure that we can specifically use to test the Istio across various platforms. On the security side, we currently do not have any kind of a CVE processes in place at all. So I think we can use your help to formalize the process. And onto the CLA side, we would like CNCF to take over the CLA from the IBM and Google to make sure that it is basically being managed at the org level. And that's all from us. Thank you, Brian, for becoming a TOC sponsor. And if you guys would like to learn more about the Istio, you can go to the GitHub, or you can just go to the Istio.io website. And we also do have our blog, so you can read more about that on the blog. With that, I would like to open it up for the Q&A, and we also have the some of the lead engineers, both from the Google and IBM, on the call. So Lynn, Sriram, Dan, Luis, feel free to jump in if you would like to answer any questions.
I have a question before I go. I've got to go in about 1 minute. Because Istio does so many different things, it would be really good to understand better how they fit together, because that really, I think, directly addresses the question of competitors. Just looking at the chat thread, you can see APM companies, hardware companies, routing companies, all converging around this set of functionality, which kind of mesh and control plane and data plane rolled up together, plus some monitoring. It's a sort of chimera project, and it'd be really good to sort of unpack that a bit, because I think if Istio is successful, it will have to have a good story for why you should use it, rather than some simpler things that don't do as much. I think that's really key to understand. And so long as we can do that, I would be supportive of moving forward with it.
I think, Alexis, one thing we'd like to do is make clear where things are pluggable, because APM came up there, and we're certainly not trying to disrupt the APM market so much as provide a way to get information from, we hope, every service running in an enterprise into that APM solution as easily as possible, with a single place to plug in. So agreed, we can take that on. I'm not sure what the right format for that is, but yes.
Yeah, I mean, it's more that it's a Google scale approach to integration, because you've got sidecars up the wazoo, and I think that's not what everyone is going to need. So just unpacking that would be great. Anyway, I have to go. Thank you very much for the presentation, everybody.
You're welcome. Good to see you again.
Awesome. Let's do another couple of questions. Does anyone else have any questions for the Istio team?
No, just this is the audience here from Red Hat. I just want to say that Red Hat, as you might have been there involved, and this is, of course, it's a non-binding support due to my participation here at TOC, but we expect Red Hat's active participation through a impressive number of engineers to ramp up in Istio pretty soon. So I'm just stating our support in this.
Cool. Thanks. I think in the interest of time, I know we have Ken's going to go over some serverless things, but me channeling my best Alexis impression, Brian Grant is going to be the acting TOC sponsor. I guess that's correct, Brian?
Yes.
So I'll just do a straw poll of the TOC. Is there anyone opposed of us formally inviting the Istio project to project proposal phase? Okay, so I'll take that as a yes to have them formally move to project proposal phase with Brian Grant as the sponsor. So thanks, Istio team, Lesh, and other folks for Dan in presenting. So hopefully we'll move discussions to the actual project proposal where people could chime in and work with the community to optimize your proposal. So with about 5 minutes left, Ken, are you on the line?
I am. You guys tell me okay?
Yeah, let's just jump to slide 56 to get a brief update from the serverless working group before we end the call and be respectful of everyone's time. So go for it, Ken.
Yeah, definitely. I'll make this fast. So slide 56 is just sort of like an overview of how we got here, right? We started back in May, June timeframe. We did an update about 3 months ago now on August 1st, but there were a lot of my joint TOC members were on vacation or otherwise tied up, so I don't think a lot of the TOC heard it. But over the next few meetings, we asked for participation and for comments on the white paper. We've had really good representation from over 25 different individuals that represent everything from the public cloud vendors like Amazon to open source projects and a lot of different companies that kind of a good spread. And we have 2 working documents now to look at. One is the white paper, which I've linked into here, and the serverless landscape, which we thought it'd be good to kind of have an overarching framework of all the different types of projects and companies that are offering some sort of serverless technology. And of course, if you want to get involved, we have a GitHub work group that you can join. This is just restating the goals. Our main goal was to basically create a white paper, which we've done. And so I feel like we've accomplished what our initial goal was. Would love feedback on that. But basically, themes of that white paper, we're trying to define serverless, which has been a lot more difficult than I expected it to be, and many meetings dedicated just to what the definition of absolute is and what the definition of almost always is, and fun stuff like that I'd rather shoot myself over. But it's important to have those discussions, and we've been having them, and good debate. And then trying to differentiate what serverless is against things like FAS and PAS and CAS and BAS and any other ads you can think of. And so that's sort of 2 of the major themes. We've also tried to describe many use cases for why you would care about something like serverless. And then we've, as part of this effort, we've provided, I think, pretty good definitions around functions and services and things like eventing. And so I feel like we're at a good point in the white paper to sort of call it done, which is on slide 59. What we'd like to do is work with the Linux Foundation and the CNCF channels to kind of look at how do we promote this and publicize this for at or before Cloud Native Con. Any questions on that next step? Okay, cool. And then the second next step is looking at a couple of different options, and we don't have time to discuss this today, Chris, but we can maybe meet in Austin to finalize it. But kind of looking at, do we want to continue to foster this ecosystem, because serverless is very early days, as we all know, and so we have opportunities to kind of create this ecosystem that could be part of CNCF, or we could just, as that next bullet describes, we could just encourage more participation in the CNCF by having vendors and open source tech developers sort of try to propose their projects to us. There's an opportunity for education, which is, I know, one of the Linux Foundation's things that they like to try to do. So we have some education opportunities. And then there's also just general guidance we could define in terms of how you sort of evaluate functional and non-functional aspects of the serverless architectures out there.
Hey, I have a question, Ken.
Sure.
Is serverless.com involved in the work group?
They are.
Yeah, absolutely.
And we got thanks to you, Brian. We got a couple of guys from Google to join the last few meetings as well, and that's been really helpful.
Okay,
especially
yeah,
for me, it's been helpful.
Okay, good. Glad to hear that. I think the most useful area would be developing a common event broker and event schema, and that's where I could see, potential for an actual project in the CNCF, because that's the number one thing that's going to facilitate interoperability amongst the different solutions. Cool.
Yeah, I think that's our number one. That's our number one ask for continuing the work group, is we feel the same way. So that's good to hear you say that, Brian. Hopefully other TOC members don't feel like completely opposed to that idea, but
yeah, and application deployment is a very different beast, because there are lots of different systems from that. There are dozens of CI/CD systems. There are approaching a dozen functions as service projects that run on top of Kubernetes already. It's very opinionated in terms of how you build, package, deploy your app, but the event side, we really need the equivalent of HTTP for event-driven applications, and we don't have that.
Awesome. So if you go to my last slide, slide 60, that basically sums up the ask, what Brian just described. We either want to continue this same work group or create a new work group that would basically start on the eventing aspect of it. So, and then the obviously the review and agree to release the white paper as an official CNCF document. So those are really the two main asks, and happy to take comments offline and continue the conversation next week and in Austin in December.
Awesome. Thank you, Ken. So
I don't know how I got through that so fast.
Thank you, and sorry for giving you only 5 minutes. So just in the interest of time, we're meeting again next week. So due to the Thanksgiving holidays in the US, we bumped up the TOC meeting to November 14th. We'll be hearing from the Open Policy Agent project, and we're going to get a readout from the storage working group. So thanks again, everyone, for your time, and look for official project proposals from.
Yeah, just want to make one last pitch to remind everybody that Cloud Native Con KubeCon is 1 month away. And so if you've not already booked your tickets to it, please do it. We have a bunch more hotels that we just added to it. And also the sponsorships are almost closed, but we do have some openings for the big party event on Thursday night. And so if you have a little bit of marketing budget left for the year, please reach out to us. It's your last couple of days to do so.
Awesome. Cool. Thanks, everyone. And look for project proposals from Spiffy and Istio. So thanks.
Thanks.
Thank you.
Bye.
Cheers. Bye-bye.
Bye.